Hello everyone and welcome. Today we're going to be talking about empirical and molecular formulas. But more specifically in this lesson we're going to be talking about empirical formulas. Okay, the next lesson we'll be talking more about molecular formulas. So what we're going to be talking about is in this lesson more specifically is our empirical formulas. So what is an empirical formula? So what I'm going to do is I'm going to maybe try an example here on a sheet of paper. Okay, so I could have compounds that followed the same pattern, essentially, same multiples. Okay, so if I had this here, let's say 6, 12, and let's do one more here. Okay, so I have these three compounds, C2 or four compounds. Sorry, I have C2H4O2, C4H8O4, and so forth. Now the names aren't important, not for this question, anyways. But hopefully, by looking at these, you can see a pattern. Okay, now each time what we're doing, they're multiples of each other. So to go from here to here, you have to multiply every single compound by 2. If I'm going from here to here, I'm multiplying everything by 3. If I'm going from here to here, I would have to multiply everything by 4. Now, as you can see, there's a pattern. There's a relationship between them. Can we put this into simplest terms? Can we reduce this anymore? Is there anything that's smaller than this? Well, yeah. So our ratio would be for every 1 carbon, I would need 2 hydrogens, and I would only need 1 oxygen here. This is the smallest ratio that we can have out of all of these compounds. This is what we call the empirical formula. It is the smallest whole number ratio. Yeah, I could probably go carbon a half, right? If I did C a half, hydrogen would be 1, oxygen would be another half. But that wouldn't be a whole number, having a half for a carbon, half for an oxygen. So we can't have that there. But we can have this one here. So this would be called our empirical formula because this is the smallest ratio that we have. All of these other ones we would call molecular formulas because each one is a different type of molecule. Okay, so this one's our empirical formula. These ones would all be classified as molecular formulas because every single molecule has its own different formula. Okay, empirical is the smallest one that you could make if they all have the same ratio, that is. Okay, so what is an empirical formula? It shows the simplest whole number ratio. Now, many compounds can have the same empirical formula. So that's exactly what I was showing you here. Every single one of these compounds, they all have the same empirical formula because all of these can be reduced back to that there. Now, molecular formulas are different because they tell us the actual number of each element, right? So if this here is what I'm looking at, this molecular formula tells me exactly what I have. I have 8 carbons, 16 hydrogens, 8 oxygens. So that's why we classify this as a molecular formula, but we can simplify this back to our empirical formula there. So once again, we have another example here. Now there is one error, and I do want to point that out. This here should say 4. Okay, now this is the same exact one that I was showing here. Okay, so once again, if we had CH2O, okay, this would be the empirical formula. This one underneath it is the next formula up, and it keeps on going. But once again, all of these can be reduced back to our empirical formula. Okay, so how do we determine empirical formulas? Okay, well, there's a whole process of doing so. There's 4 steps essentially, but I may add more if need be. I think we'll be okay with 4 here. But once again, I don't want you to memorize these steps. I just want you to know how to do these questions. So what we'll do is we're going to jump right into a question to get a better idea. And then we'll come back here and it should make sense. Okay. For our first question here, it says a compound is found to contain 50.05% sulfur and 49.95% oxygen. What is the empirical formula for this compound? So if you remember from our last lesson, we talked about a mass spectrometer. Okay, so a mass spectrometer is where you get a certain amount of mass of a compound. You get some sort of solid compound typically. You put it through the machine, and then at the end of the machine, it's going to tell you what percent you have. So that's exactly what we did here. This time we had, the machine told us anyways, we have 50.05% sulfur and we have 49.95% oxygen. So what we're trying to figure out is, what is the compound? What is the formula for this compound here? Okay, so in order to do this, we need to do a couple of steps. The first step. Okay, step 1. Assume 100 grams. Okay, step 1 is to assume 100 grams. Now, you can assume anything. You can assume 1 gram, 10 grams, 15 grams, 2 grams. It doesn't really matter. Okay, now the easiest one to take would be 100 grams. And the reason why we would take 100 grams is because that would just make our percentages turn into grams. So what I mean by that is we know that we were given a compound and we put it in that mass spectrometer machine and we got these numbers here. The question is, how much were you given? Well, it doesn't say. So we need to assume a weight, okay? So we don't know how much we were given, so we need to try and figure out what weight we have. So we can assume any weight we want. We can assume having 1 gram. We can assume having 2 grams. But the easiest one to assume is 100 grams. And the reason why it's the easiest is because what's going to happen is now, okay, little m stands for mass. So the mass of sulfur, which is S, is going to be 50.05 grams. The mass of oxygen is going to be 49.95 grams. Okay, so you could have assumed 10 grams. Let's say you assume 10 grams. You need to keep these percentages similar. So if you assume 10 grams, you would have had 5.005 grams. And you would have had 4.995 grams. So do you see how the percentages would stay the same, but the numbers would change? So if you don't want to have to do an extra step, the easiest thing to do is to always assume 100 grams, because then all you have to do is just change your percentages, because your percentages are already in terms of 100, and you just change those percentages into grams. So that's our first step. Okay, we need to change these percentages into grams. The easiest way is to just assume 100. So step 2. Okay, we need to convert to moles. Okay, as you guys already know, we don't work with mass, we typically work with moles. So in order to do that, we need to use this here. So the first one is sulfur, so I'm going to put S like that. Okay, so once again, our molar mass formula is this here. Molar mass is equal to mass divided by moles. And we're looking for moles, so we need to do a little rearranging. So moles is equal to mass divided by molar mass. So we need to input our numbers. So the mass that we have for sulfur is 50.05 grams. And we're going to divide it by the molar mass of sulfur. So if we look at our periodic table, it has 32.07 grams per mole. Now, as you guys know, the grams are going to cancel each other out. We'll be left with moles. That's what we're looking for here. Okay. Now, the more decimals you take, the better your answer will be. So if this one I only took 2, but I think in the future, the other ones I took 4. Okay, the more decimals you take, the more accurate your final answer is going to be. So I have 1.56 moles of sulfur. How about oxygen now? Okay, so once again, I'm not going to show that first step, but I do know that moles is equal to mass divided by molar mass. I already did it. So then we have our mass of oxygen, which is 49.95 grams. And we need to divide it by the total molar mass of oxygen. Molar mass of oxygen is 16.00 grams per mole. Once again, grams cancel out, grams cancel out. You're left with moles here. And the moles that we get are 3.12 moles. So that's step 2. Okay, nice and easy. We're just converting to moles. Okay, step 3. Divide by smallest amount. Okay, now once again, you should know that amount means moles. So what we're going to do here is this. We're going to look at both of these numbers that we got. Which one do we have less of? Well, obviously this number is smaller, so we have less of this here, which is our sulfur. So what we're going to do is we're going to divide both of these numbers by the smallest one, by the smallest amount. So what I'm going to do is I'm going to take my moles of sulfur and I'm going to take my moles of oxygen. Those are the 2 numbers here. Moles of oxygen is that. Moles of sulfur is this one. Okay, so I'm going to take both of them and I'm going to divide them both by the smallest. So the smallest number here was sulfur. So I'm going to divide moles of sulfur by moles of sulfur and moles of oxygen by moles of sulfur. Okay, so what that means is this. I take 1.56 moles and I divide it by 1.56 moles. For oxygen here, I'm going to take 3.12 moles and divide it by 1.56 moles. So as you can see, I'm taking both of these numbers and I'm dividing them both by the smallest. Now, if you did this work correctly, you're always going to have one number that comes out to exactly 1. Okay, now if you take a look, both the moles cancel out, both the moles cancel out. Dividing the first one, we get 1. Dividing the second one, we get 2. So the third step, or fourth step, sorry. Okay, the fourth step is to put everything together. Okay, so step 4 is this is where we complete it. So what this means, we have a 1-to-2 ratio. So for every sulfur, we have 2 oxygens. Okay, because sulfurs came out to 1, oxygens came out to 2. So we have a 1-to-2 ratio between sulfurs and oxygen. What that means is that for every 1 sulfur, I'm going to put S1, we have 2 oxygens. So therefore, our empirical formula becomes SO2, sulfur dioxide. And that here is our empirical formula. Okay, so we have 4 steps essentially. First one, we convert our percentages into grams. So we have to assume 100 grams. Next, you take those grams, you put them into moles. Once you put them into moles, we need to divide by the smallest. And after we divide by the smallest, then we can figure out what we have here. All right, let's move on to example number 2. Okay, for this one here, let's go ahead and let's try this out. Okay, if you would like to pause the video, you can. I will say at the end spot, so once you get to this part, step 3, it's going to be a little bit different. So what I recommend, try step 1, step 2, step 3 by yourself. And then when you're done that, maybe you want to resume the video and I'll go through it to see if you got it right. And then I'll show you step 4. Okay, so if you'd like to do that, you can now. Okay, so hopefully you did pause it and tried it out. Okay, so I'm going to do step 1 over here. Okay, hopefully you can see that. Yes, you can. Okay, so step 1. You need to always have this. Okay, I will be looking for this. Assume 100 grams. I will be looking at this because I don't know what you're assuming. You need to tell me what you're assuming. Are you assuming 100 grams, 10 grams, 1 gram? You could use any of those numbers and you'd still get the right answer. It's just that you're going to do a little bit more math than you would need to. So I'm assuming my 100 grams. So my mass of magnesium is going to be 72.2 grams. And my mass of nitrogen is going to be 27.8 grams. Okay, so that's step 1, already done. Nice and easy. Step 2. Okay, this is where we need to convert to our moles. Okay, so once again, I'm going to do magnesium first. Okay, so once again, I already showed how I rearrange the equation up top. On a test, I would want you to show me. As of right now, because this is just our lesson, we should know that we have moles is equal to mass over molar mass, right? Once again, I'm taking this formula here, my molar mass formula, and rearranging to get this. So that's what I have here. So my moles is going to be 72.2 grams, because that's the mass of magnesium, divided by the molar mass of magnesium, which is 24.31. And that's grams per mole. Okay, grams and grams cancel out. I'm left with moles. Now this one I took more decimals to be a little bit more accurate. Like I said in the previous question, I took 9,699 moles. Okay, and lastly I need to do nitrogen over here. So I know my moles is equal to my mass. Once again, I'm just for space sake. Okay, so it's my mass divided by my molar mass. Nitrogen is 14.01 grams per mole. Both my grams cancel out. I'm left with moles. I'm taking 4 decimals. And I got 1.9843 moles. Okay, so that's step 2. All right, step 3. This is where we divide by our smallest. So once again, looking at both of these, my moles of nitrogen are smaller. So I'm going to take, once again, moles of magnesium. That's what that stands for, moles of magnesium, divided by my moles of nitrogen. And I can do the same thing here, moles of nitrogen divided by my moles of nitrogen. Okay, so for this one here, I get 2.9699 moles divided by 1.9843 moles. On this side, I have 1.9843 moles, and I divide it by the same one. Now, if you remember what I said last time, you know you did it correct if you get exactly 1. So once again, moles and moles cancel, moles and moles. So for this one here, after I did that, I got a 1.5. Okay, 1.497, which rounds to 1.5. And for this one here, I got, once again, exactly 1. So Step 4, kind of running out of room here, but I'll do step 4 over here. Now, what this tells me is that I have magnesium 1.5 and I have oxygen 1. Now, can I have a half of magnesium? Well, no, I can't. So what we need to do is we need to up this into the next whole number, which preserves the ratio. Okay, so for every 1.5 magnesiums, we get 1 nitrogen. So what would be the next whole number that we could do? Well, what we could do is we can multiply 1.5 by 2 and oxygen by 2. So I'm going to multiply everything by 2. And when I do this, 1.5 times 2 is 3, and oxygen becomes 2. So this is the same ratio as this one here, but it's the simplest whole number ratio. And once again, if you remember your empirical formulas, it's the simplest whole number ratio. We can't have a half or 3/4 or whatever the case is. It has to be a whole number. Okay, so that would conclude our step 4 here, and that gives us our molecular formula. Now, what I want you to do, okay, here's a little bit of a chart that I'm going to help you guys out with just right now, okay? So on 1, it's going to be a T-chart, okay, like that. So if it ends in is 1, and then multiply by. Okay, so in the last question, we had magnesium and it ended in 0.5, right? It was 1.5. So because it's ending in 0.5, okay, maybe I'll get rid of that 0. I don't want to confuse people. Okay, so if it ends in 0.5, you multiply both by 2, and that will give you the simplest whole number. If it ends in approximately 3 or very close to that, well, we're going to multiply it by 3 because that will round to a whole number. It might not be exactly 1, but it's going to be very close where we can take that assumption. Okay? If it ends in 0.25, well, we multiply it by 4, right? That's our quarters. And if it ends in 0.20, we multiply it by 5. Typically, we're not going to see much less than that. These are typically the normal ones we see. But once again, this here is kind of a little bit of a helper to help you out. So I would write that down somewhere. All right, now the last question. Okay, it's this one here. So this one's just a little bit longer. It's not much harder, but it's just a bit longer, okay? And the reason why it's longer is now we have four elements instead of just 2. So what I want you to do, once again, pause the video, try it out, and then when you are ready, resume it and see if you got it right. Okay. So for this question here, I'm going to do it on a sheet of paper just because this one's a bit longer. Okay, so once again, you should have written this all down. If not, you could pause it and write it down. So let's go ahead. So we have, I'm just going to write at the top here to remind myself anyways. So we have 57.14% carbon. We have 9.52% nitrogen. Oh, I forgot hydrogen, sorry. 6.16% hydrogen. And 27.18% oxygen. Now, a question I typically get is what order should the compounds stay? Typically, just keep them in the exact same order that they have in the question. Okay, so carbons come first, hydrogens, nitrogens, and then oxygens. So that's why I tried to keep them in the same order. So step 1. Okay, we're going to assume our 100 grams. Once again, I need you to put that somewhere on your sheet. I will be looking for it. So, the mass of carbon. Once again, let's try to get into proper notation. So we have 57.14 grams. The mass of hydrogen would be 6.16 grams. The mass of nitrogen is going to be 9.52 grams. And the mass of oxygen is going to be 27.18 grams. Okay, so that's step one, nice and easy. Step two. Okay, this is where we get our moles. So, first one is carbon. Okay, once again, this is your molar mass formula. We are looking for moles. So we rearrange our equations and then we plug in our number. So our moles is going to be our mass, which is 57.14 grams of carbon divided by the weight of carbon, which is 12.01 grams per mole. Both the grams cancel out. We're left with moles. Okay, I took 4 decimals again. 4.7577 moles. Okay, so that's carbon. Next, we have hydrogen. Okay, so once again, our moles is going to be our mass. So once again, I've already did my rearranging, so that's fine. I don't need to show it again. So I already know that my mass is going up top. If you show it once, that's fine enough. Okay, so we have 6.16 grams divided by 1.01 grams per mole. That's for hydrogen. And that's going to give us 6.099 moles. Okay, next we have nitrogen. My lead. Okay, so my moles of nitrogen are going to be 9.52 grams divided by 14.01 grams per mole. Both your grams cancel each other out. Left with moles, same thing here. I forgot to show that. And you'd get 0.6795. So as it stands, this one is the smallest. But the last one, I'm going to fit it over here. Okay, so I have my moles. So it's going to be 27.18 grams divided by 16.00 grams per mole. Grams cancel, you're left with moles, and our final one here is 1.6988. All right. So that's what we have here so far. Okay, step one, step two. So now we need to go to step three. Okay, so step three is where we divide by our smallest. Okay, so once again, I'm going to split this up. So we have carbon here. So for carbon, we're going to take our moles of carbon and we're going to divide it by our moles of our smallest, which in this case is our nitrogen. Okay, so our moles of carbon was 4.7577 moles, and we're dividing it by the smallest, which is 0.6795 moles. So dividing this here, we get 7, or very close to 7, so that's a good, nice whole number for us. Next is hydrogen. Maybe I'll do it a little bit further out. Can you guys see this? Good. So for hydrogen here, once again, we're taking the moles of hydrogen, dividing it by our moles of nitrogen. Okay, so hydrogen is 6.099 moles. And we're dividing it by our smallest, which is 0.6795 moles. Okay, so this gives us about 8.98, which is very close to 9. Okay, next we have nitrogen. Once again, this is the one where we're going to have dividing by the same. So this one should give us our 1. And once again, you guys already know, if we get 1, we should be, we know we're on the right track. Okay, so everything cancels out here, so we get 1. And the last one we have is oxygen. So our moles of oxygen divided by our moles of nitrogen. So we get 1.6988 moles, and we're dividing it by our 0.6795 moles. This one here gives us 2.5. So as you can see, we already have one of those 0.5s. So as of right now, we would get C7H9N1. I'm just going to put it here just to show anyways. And we all know that we don't put the 1 there. And we have O2.5. So what am I going to need to do to get a whole number? And sorry, I'm just going to move this a little bit down so you can see. So what can we do to get a full number here? Well, we're going to have to multiply every single one by 2. And when we do that, we would get C14H18N2O5. And that is our empirical formula. Okay, so once again, you're given your percentages. Okay, you're going to assume 100 grams, get your grams, take your weights, change them into amounts, right? Those are our moles. Whichever one's your smallest amount, in this case it was our nitrogen. We're going to take that number, divide them all by the smallest. Those numbers give us our ratio. Once again, we don't want a 0.5, right? If you get a 0.25 or whatever the case is, we need to change those into whole numbers. So we do that there. And once again, that's what this was saying earlier in this lesson. Okay, so if we go back to here, okay, so first we need to assume our mass is 100 grams. Once again, you don't have to put 100, you could put any number, but as long as those percentages match up. Okay, determine the amount, so we're changing to moles. Okay, divide each one by the smallest. And then the last step is where we have to multiply if you get 0.5 by 2, 0.33 by 3, so forth. And that's what we get there. Okay, thank you for watching. Hopefully this made sense to you, and have a great day.